Why does artificial intelligence hallucinate? Large language models hallucinate because they are mathematical probability engines, not factual lookup systems. When you prompt an AI, it does not query a database, read a stored article, or evaluate whether a statement is true or false. It calculates the statistical probability of the next word in a sequence based on hundreds of billions of numerical parameters trained on raw text. In 2023, Google lost $100 billion in market value in a single day because its AI chatbot, Bard, incorrectly stated during a live demo that the James Webb Space Telescope took the first picture of an exoplanet. The system didn't crash, and it didn't suffer a code bug. It generated text where the calculated probability of the words sounding correct outweighed the factual accuracy of the underlying data. How the math drives the output. At a technical level, every output an LLM generates is driven by an auto-regressive prediction function. The probability of the word at position t, or the target token, given the previous context equals the softmax of the neural network's output. The model converts your prompt into high-dimensional vectors, processes those vectors through its transformer layers, and outputs a probability distribution over its entire vocabulary. It then selects the next token based on those probabilities. Because the model is trained to minimize cross-entropy loss across trillions of sentences, its primary objective is to generate fluent, contextually coherent sequences of text. The parameters encode statistical patterns, which words tend to follow other words, rather than deterministic knowledge. When probability aligns with fact, the output is accurate. When probability diverges, the system confabulates plausible-sounding fiction. Technical causes of hallucination. 3 structural factors cause this prediction process to fail. First, information compression. Training an LLM requires compressing petabytes of unstructured text into a fixed set of network weights. High-level syntactic patterns and broad relationships survive intact, but precise factual microdata, like specific dates, exact numbers, or legal citations, get degraded. When forced to output a degraded detail, the model generates whatever token best completes the sequence syntax. Second, optimization for fluency over truth. Standard training and alignment protocols penalize broken grammar and disjointed logic far more heavily than factual errors. The reward functions incentivize the model to maintain a confident, articulate tone, even when its predictive confidence for a specific fact is extremely low. Third, sampling stochasticity and temperature. To prevent repetitive, deterministic responses, decoding algorithms introduce randomness, controlled by a setting called temperature. Raising the temperature flattens the probability distribution, forcing the model to select lower probability tokens. On obscure or underrepresented topics, this added randomness causes the generation path to drift entirely into fabrication. Architectural mitigations. Hallucinations cannot be removed purely by retraining the model, because the mechanism that generates false statements is the same mechanism that allows the model to summarize, translate, and rephrase text. Instead, production environments isolate the generative engine behind a structural boundary called Retrieval-Augmented Generation, or RAG. Under RAG, an external search pipeline queries a verified database first, retrieves grounded source documents, and feeds those documents directly into the model's context window. The LLM is restricted to synthesizing the provided reference text rather than relying on its internal parameters for factual retrieval. Ultimately, large language models process syntax, not semantics. They calculate what word comes next, not what state of the world is true. Understanding that fundamental design boundary is the key to deploying, building with, and verifying generative AI systems effectively. To learn more about our law firm's legal practice in the areas of technology and artificial intelligence, we welcome you to visit our website and contact our law firm to schedule a confidential consultation. Thank you.